Alright, hello ladies and gentlemen. Welcome to the video on section 3.4, Communicate with Algebra. I will be your host, Mr. Neto, and take you on this journey as we continue through this section. So, we're going to be talking about algebra. What is algebra? Algebra is going to be the most important thing and the most important concept throughout your entire high school career. So let's get started with it. What is algebra? So algebra uses symbols to represent information in a compact form. So, for example, in algebra, if you were to transform 3 times a number plus 6, you would write, well, we'll think of something as whatever a number is. So we can use any kind of symbol, but majority of the time we use letters. So 3 times a number, I'm going to write it like this. 3 times a number, and notice that they are side by side like this, which means that they are being multiplied. So this is 3 times a number, and then it's supposed to be plus 6. So we got plus 6. Awesome. All right, so now I want you to notice how we've got a little bit of a separation here. We've got this guy over here, and we got this guy over here, okay? So what we call these, okay, so we talk about 3n and 6 are called terms of the expression, okay? So a term, what does that mean? Is a number or a variable or the product of numbers and variables. So it's a number or a variable or the product of numbers and variables. All right, so some examples of terms. I want you guys to try and think of some. I'm just going to write some random ones that might come to mind. For example, we could have 7. Okay, we could have x. We could have 7x. We could have negative 7x. You could have 5y. You could have z or z. You could have a. You could have 5 or 15. Let's make it 15b, and so on and so forth. Hopefully, you get the hint or you get the idea of what that is. All right. Now, we have these different terms. So you've seen stuff where it's just a number, just a variable, or a product of two together. In fact, let me give you one more that you can see. What about 1/2 x? Okay, again, you got a fraction, but that is also the product of a variable. Well, sorry, product between a number and a variable. So that's also a term. So now let's break down the ones where we have a number and a variable together. And let's see what it's called, okay? So in this situation, we're going to look at 6D. And whenever we get a term like that with a number and a variable, the 6 is always going to be called the coefficient. Efficient. I before E except after C. So I think I've spelled this wrong. Okay, forgive me if that's the case. C-E-I-N-T. I think it might still have been the other way around. Anyway, D is called the variable. Okay, so in other words, just to repeat, if you've got a term where you've got a number and a variable, the number is called the coefficient, and the D is the variable. Okay, now if there is just a number by itself, this would be called a constant. All right, if the number is just by itself, like this 6 over here, and the plus 6, this is a constant. Your variable, this is the, what's it called? Right, coefficient. Okay, let's move on. And just like I said, a constant is a term that contains, now you know it, a number. Okay, and this is only a number. Okay, its value does not change because a constant, the number 2 will always be 2, no matter what it is that you say. The number 3 will always be the number 3, no matter what. Now, for example, if we were to write down, just for the heck of it, if I were to write 3n, now this number could always change, right? Because depending on what n is, if n is 2, this gives me 6. If it's 3, this gives me 9. So this can always change with the variable. But with the constant, the number will always be the same. Okay, so let's look at these next expressions and identify the terms, the variables, the coefficients, and the constants. So let's see if you can talk it out by yourself. If you want to pause this, take some guesses, that would be great. And then you can play it and you can get the answers. Okay, so if you want to hit pause now. All right, and if you didn't hit pause, then you want to just see what the answers are, and that's not fun. But we'll do it anyways. Here we go. How many terms is there? 2 terms. Okay, we got 1 term, 2 terms. Variables. That's a trick because it's not variables, it's just a variable. And the variable is x. How about the coefficients? How many are there? If you said 1, you are correct. Coefficient is 5. And the constant is 9. All right, hopefully you were able to get all of that. Let's take a look at the next one, though. All right, the next one is, how many terms do we have here? You've got 1, 2, 3. And the big thing that you have to know, the way that terms are separated. Okay, you got to make sure you write a note here. The way that a term is separated is because of these guys. All right, the pluses and the minuses. Okay, the positives and the negatives, the plus and the minus, should I say? Those are what separate terms. Okay, not the multiplications. All right, it is the plus and the minus that separate them. So in this situation, how many terms do we have? Right, we have 3 terms. And what we would call something with 3 terms is a trinomial. All right, and the one with 2 terms, the one above, is a binomial. Okay, so you can guess what it is if there's just one, and that would be a monomial. Good job. Okay, so variables in this situation, y. Now, does it matter about the exponents at the moment? No, because we're just looking at the variable. Okay, if there were other variables, then we would be considering them, but we don't. It's just y. Coefficients. That's right. It is 12, and it's 7 and -6. Now, if you're wondering what the heck is he talking about, it's not -6. You are correct. Haha, you have seen my plan. So the coefficients were just 12 and 7, and our constant is -6. Okay? All right, let's go to the next. Okay, so now again, we're going to talk, I'm always getting ahead of myself, but now we're going to just talk about what it means with how we classify these polynomials. Okay, so a polynomial is an algebraic expression formed by adding or subtracting terms. See that? The only way to do it is by adding or subtracting terms. Guys and ladies and gentlemen, please, star. Okay, very, very, very important, okay, for you to understand that. Now, let's look at the types of polynomials. Monomial, 1 term. Binomial, 2 terms. All right, here's some examples. Boom, boom. Let's look at some monomials. There's 1, there's 2, there's 3. Notice 1 multiplication, 2, 3, 4 multiplications all together, but still 1 term. All right, back to binomials. 2 terms. How are they separated? Plus, minus. Trinomial is 3 terms. 1, 2, 3. Okay, hana, dul, set. That's some Korean for you. Now, let's take a look here and let's try the example. Let's classify each polynomial by the number of terms it has. So, please hit pause, give it a shot, then hit play. Okay, so we've got 1, 2, because it's been separated by the plus, so we've got a binomial. All right, the next one, we have -4y, but it is just 1 term, so we call it the monomial. And last but not least, let's take a look at the third one. We got, there's a minus, there's a plus sign, so we got 1, 2, 3, and with 3, it's a trinomial. Okay, you guys are on the ball so far. Let's keep this rolling. Okay, now, we're going to talk about degrees. So we've talked so far about what a variable is, what a constant is, what a coefficient is. We've talked about a monomial, binomial, trinomial. So now the next thing we need to talk about is the degree of a polynomial. So here's what it is. The degree of a term is the sum of the exponents on the variables in a term. So in a term, meaning one term, we'll look at the term and we take the sum of the exponents on the variables. I'm going to underline variables because it's not about the constants, or sorry, the coefficients. Okay, it is the variables. So let's remember something. When no exponent appears on a variable, the value of the exponent is 1. But you guys knew that already. If a term has no variables at all, the degree is 0. Okay, goose egg. So let's find the degree of each term. So in this one, in A, how many terms do we have? In this situation, we only have one term, and we have a 3 above our variable. So the degree of this term is 3. Okay, let's take a look at the next one. The next one, we are looking at only the variables. So we've got a squared, but we also have this b to the power of 1. Let's add these two together, and their degree is 3. Again. Now let's look at the last one. Last one, degree is 1, right? Okay, so you should be checking, and you should be saying, Mr. Neto, you got to make sure that you know what you're saying, because we don't have a variable here. No variable, then there's no exponents to add. Therefore, it is a big old goose egg. Okay, the degree is 0. Okay, so now let's look at the degree of a polynomial. We looked at one term, but what happens if we have many terms? How do we decide what the degree is? So in this situation, the degree of a polynomial is the degree of the highest degree term. So we got to find the degree of each term, and then we look at the highest one, and that's how we decide what the degree is. So let's look at this example. Circle the term with the highest degree and then state the degree for each polynomial. So let's work it out. So in the first one, okay, we got a variable in the first one. So it's 1 for that term, and in the second term, it's 0. So highest term, and our degree is 1. Take a look at the second one. The second one, we've got 3 as our degree in the first one. Now let's take a look at the second one. We've got a squared, so you must think it's 2, but don't forget, b is to the power of 1. If we add those together, we also get 3. So this one was a little bit of a trick question because they are both the same degree. So we just say that the degree is 3. All right? Okay, last but not least, let's take a look at the last one. If you want to pause it and work it out, go for it. If not, keep listening. We've got here the first term, add these two up, it is 6. And the second one, we add them up, don't forget about that special 1 hanging out over there, and it is 7. So what is the degree of this term? It is 7, and here is our highest degree. This is the term with the highest degree. Okay, so hopefully that made a little bit of sense to you. All right, almost done. Let's take a look now at some applications. So an arena charges $25 for gold seats, $18 for red seats, and $15 for blue seats. So write an expression that describes the total earnings from seat sales. Identify the variables. All right, so we really want to make sure, guys, that we do this. You want to always identify your variables at all times. So we're going to start with our let statements. I'm going to say let G represent, I'm just going to put REP, okay, represent the number of gold seats. All right. Then we're going to say let R represent the number of red seats. And then let's say let B represent the number of blue seats. Oh, well, I didn't need to write that down, but I did. But let's just keep it with continuity, and we'll just use the ditto signs. Okay, so now we need to write an expression that describes the total earnings from seat sales. Okay, so we got to figure something out. So in order for me to figure out the sales, I know that if I take the number of gold seats and I multiply that by 25, right, that'll give me how much it is for gold seats. So let's just write that down. Okay, I'm going to use a different color now. So let's go and we're going to write down, okay, well, 25G. All right, because that tells me if I know the number of gold seats, multiply that by 25, that gives me how much? We're going to say then it's $18 for red seats and $15 for blue seats. But now we got to write the expression that describes the total earnings. So in order for me to find out what the total earnings are, I'm going to add them together. Okay, beautiful. So there we go. We now have an expression that describes the total earnings. So let's go to B now. How much will the arena earn if it sells 100 gold seats, 200 blue seats, and 250 red seats? Well, the good news is we already have an expression to figure that out. So I now know how many gold seats, I know how many blue seats, and I know how many red seats. So let's just take that and we're just going to sub those in, and we're going to actually solve this wonderful problem. So let's take 25, and I'm going to change the G to 100, but I'm going to make sure that I put the 100 in brackets. Okay, so notice that they are in brackets, and that way I always know that I have done some sort of substitution. It reminds me that I've done that. Also, it lets me know that I've got to multiply it. Plus 18 times R, and R represents our red seats, as I can see right over here. So we're going to put in there 250 plus 15 times blue seats, which are going to be 200. Okay, so I'm going to let you guys do the math, and then you will see the answer shortly. All right, and so there you go. There's your answer. So we've just multiplied the 25 times 100. We multiplied 18 times 250, 15 times 200, and then we added them all together. And that gives me 11,000. And I'm going to put my units now in there, $11,000. And please make sure, ladies and gentlemen, that when you finish all of this stuff, you always have to write a concluding sentence. So, therefore, the arena will earn $11,000. Okay, you will lose a mark if you do not write the communication sentence. So in other words, that you didn't answer the question. You just did all the work, but you never actually answered the question. So I can't give you a mark if you haven't answered the question. Okay? All right, so we are done. You made it through this lesson. There is your homework, ladies and gentlemen, okay? Remember, it was a section 3.4, so you can just go to that in your textbook. Please do the following numbers, all right? And if you have any questions, we will take it up tomorrow. All right, guys, have a great rest of the day. Enjoy, happy studying, and we will talk to you soon. This is Mr. Netto, over and out.